John Elliott from Ebac. We're at your production facility in Newton Aycliffe, County Durham, and behind us we can see a production line making
washing machines. That's right.
Now, this is the only washing machine factory in the UK, isn't it?
We're the only manufacturer of washing machines in the UK, that's right. And it's selling very well. We get very good feedback on Trustpilot. We've made a product that's reliable, and people know that. Washes well, selling very well.
Excellent. And you also make at this factory water coolers. Oh, yeah. You also make at this factory water coolers and domestic dehumidifiers.
That's right. Domestic dehumidifier sales are increasing a lot. It became very apparent over the cost of living crisis that a dehumidifier is a better way of drying laundry than a tumble dryer. A tumble dryer takes 1500 watts. A dehumidifier takes 150 watts. So that's increased demand of dehumidifiers quite significantly.
What's the next product you're going to introduce to production lines like this?
The next product we're going to make this year is heat pumps. We've developed a range of heat pumps which are very energy efficient, and heat pumps are the heating system of the future, no doubt about that. Electrically driven, and that will be the energy of the future looking forward. Gas boilers are going to become obsolete, and they're going to be replaced by heat pumps. We've designed the product. We've been making heat pumps a long time actually, in small volumes. We made the very first one 30 years ago.
Wow.
But we're now using latest technology and digital. We've got very high efficiency. We've got a COP of 4.99 at 7 degrees centigrade, which is unbelievable.
Can you show me your test centre?
Absolutely.
Which way?
Yeah. This is our test chamber here. We can control the air conditions we go from minus 15 to plus 60. So
Right.
we can control those conditions so we can test. It's always best, you've got to do a test in controlled conditions so we can measure the performance. You can't rely on ambient conditions. This is where we test things like dehumidifiers and heat pumps.
And that's what you got in there.
That's
the
what
new
we've got in
heat
there
pump.
now.
Can
Yes.
we go and have a look in, because you got the backs off? Wow. It's nice and warm in here.
Yeah, this is because they'll be doing a test here, electrical test. They'll never run in this condition, but you've got to test products in a wide range of conditions to make sure that there's no problems there.
So this is the inside of one of your heat pumps.
This is
Just talk us through what bits are which.
Right. The electronics is fairly complicated. Half of that is to do with an inverter which controls the compressor. The big improvement in refrigeration circuits over the last 10, 15 years is a digital motors driven by inverters. Which means you can control the speed and get much more energy efficiency with a conventional compressor.
Right.
And the rest of it's to do with the control system. The key thing, heat pumps, you just can't replace a boiler with a heat pump. You've got to change other things as well, and the control system is important. This is about being efficient. And part of efficiency is controlling it well and at the right times. So the control system is to do with controlling the conditions inside the house.
And what about this bit?
That's the fan that pulls the air through the system. What a heat pump does is it takes heat out of the air, and then what it magically does, it converts that heat to a higher temperature so you can heat water.
And where does it do that?
That's the compressor, and that changes the heat. The surprising thing is, even air at minus 10 has got heat in it. To us it feels very, very cold. If you cool the air down from minus 10 to minus 20, you've got 10 degrees of heat. So this has got the ability to absorb heat in low temperatures and then raise the temperature and get that heat back. So it doesn't produce the heat, it just moves it. And that's why 1 kilowatt of electricity produces 3 or 4 kilowatts of heat.
We are in Ebac's boardroom now, looking at some of the great products they make: water coolers, washing machines, dehumidifiers, and this is the new one, the air source heat pump. John, this is the real deal, isn't it?
This is the heating method of the future. There's no doubt in my opinion that the energy of the future is going to be electricity, from renewables or whatever. That's going to be the energy of the future. And if you've got electricity, this is the best way to heat the home. This can take heat from the air outside, even when it's very cold, and use that energy inside the house to heat the house.
Now, if you had a 3-bedroom semi-detached house, where would this go?
This is the size for this is a 9 kilowatt unit, which will be right for a 3-bedroom semi. This will go outside. It's got to go outside. It's got to be at least a foot from the wall, and then all we've got to do is bring electricity to it and take the 2 water pipes to the heating system.
Now, it will then produce hot water that goes into the heating system. What will be the temperature of the water?
That depends on the design, and that's key. The key to air source heat pumps, there's many urban myths about air source heat pumps, and they always down to bad application. That's why we wouldn't sell to the general public. We sell through dealers who we recommend. And that's getting better, actually. There's people like Octopus now in the business and British Gas, which are doing a good job. So it's got to be installed correctly. You can't just replace a boiler.
Mm-hmm. And the temperature of the water then will maybe be different for different houses?
Could be. It depends on what you've got inside, what you're doing. I've got an Ebac air source heat pump, running it for 3 or 4 years at home, and I've managed to heat my house with water never getting above 40 degrees. The colder it is outside, the hotter you need the water.
40 degrees is quite hot for radiators, though, I suppose.
No, a radiator if you design a radiator for a gas boiler, it could work at 60 degrees centigrade. And that gives you more heat. And
the ambient temperature of a house is 19, 20, 21?
Yeah, 21, 22. So 40 degrees can do it, but as long as it's designed properly, that's key to it. So it may mean you've got to increase your radiators or change the design using a fan-assisted radiator. It's got to be designed properly. That's why we sell only through reputable installers.
Will the hot water produced by a heat pump be hot enough for a bath?
Yes. So you can, for example, to get water for domestic hot water at 50 degrees C is okay. It's slightly less efficient for the last 10 degrees, but that doesn't matter. And a bath, normally 40 degrees, is about the right sort of temperature.
Now, this goes outside, but is it noisy?
No, it's not silent, but you can't hear it inside, and you can't hear it if you're a few metres away from it. You've got a fan here, which is well designed, and it runs quite slowly. Again, quietness is quite important, so it's designed to be quiet.
So this product, the price is really important, isn't it? This piece of machinery, I suppose, dictates the price of an installation because it's the most important piece of machinery.
It is, and I would expect the retail price for this, for less than 4,000, it's somewhere in the 3,000s. That's where the retail price of this is.
Right.
Now, and of course, remember at the moment, if you buy an air source heat pump system, there's a £5,000 subsidy from the government. And I'm sure the government will continue to support them as well. So
it can be done.
It can be done. There are other costs to do with the installation.
Now, this is being made here in Britain, and I know you're very passionate about British manufacturing. Do you think this kind of product, a new product, does need to be made in Britain, or do we risk, if we don't make them, sucking in imports?
Absolutely right. We've got to make more things in the UK. It's that simple. We've never balanced the books without more manufacturing. The sooner we realise that, and I'm afraid those in government don't realise that, the better. And of course, we understand the British market. This is the most energy efficient heat pump on the market today in UK conditions because we understand UK conditions. We've got lots of experience with dehumidifiers where defrosting is very important. We've got a defrosting system here which makes it more energy efficient. And as I say today, this is the most energy efficient heat pump you can buy in the UK today.
And can installers buy this from you now?
Manufacturing starts in about 3 months' time. The middle of 2023 we'll start manufacturing in volume.
You also have a new product that's coming for British households. What kind of product is it, and can we have a look?
It's a ventilation system designed for controlling condensation dampness and also better air quality. Let me take you to the labs and I'll show you the product in development.
John, you brought us to the lab for future products. This product looks like a box. What's in it?
This is a ventilation system which has got two functions. One is to ventilate. More and more in modern houses which are well sealed need ventilation to get better air. But also it's a very good means of doing dehumidification. Now we've got 30 years experience of selling dehumidifiers. We sold nearly 2 million in the UK to control condensation dampness. This is a better way of doing it, a bit more expensive. This simply takes the air out of the house which is full of moisture and throws it outside. Now we could do that ourselves by opening the windows, and some people do have ventilation systems. The problem with that for dehumidification is it throws heat away as well. It's midwinter and you've got the house at 20 degrees and outside 0. You're throwing heat away. And that's why a dehumidifier, refrigeration dehumidifier, is more cost effective to control condensation and dampness than ventilation. But what this system does, we've got a heat exchanger in this system, surprisingly made in the Ukraine, by the way.
Oh, right. And that goes in that hole,
that goes in here. So what we do is we take the air from the home outside with its excess moisture, but then we pass the air from that's coming in to replace it, past the air going out which is warm, and transfer the heat from the warm air going out to the cold air coming in, so we don't lose the heat. We recover heat for nothing.
Wow, that's
so
great.
This means it's a low running cost on a dehumidifier, and it controls the problem just as well.
So these ventilation systems, you've got a mini production line going to get the first ones made.
That's right. We've just started making these. It's something we're very familiar with. The technology's part of our DNA. And the market of dehumidification, of course, we've been in that since we started the business 50 years ago. So it's a natural follow-on and a very interesting product.
And when will it be available to buy?
It's available to buy now.
Right.
It's gone through all the testing procedures, we've got all the approvals. We're now starting to make them and sell them.
And have you decided on the price? Because it is very new.
Yes, we've got a range of prices. It depends how much you do inside the house. If you just take it there simply as a dehumidifier, it's relatively cheap compared to if you want a full ventilation system, especially in an existing house, putting that in. And unfortunately, the building regulations for ventilation is quite complicated. Unnecessarily complicated in my opinion, which makes it quite expensive. So we've got two options here. One is a dehumidifier, which just simply fits in the attic, usually, or it could be in another room, and it's got two ducts going outside, and two ducts into the house, and then the moisture migrates at that point, and the CO2 as well. As well as taking out moisture, it also takes out CO2. Now, it isn't common knowledge. The normal CO2 outside there normally is about 440 parts per million. Inside your home, when it's closed, could be as high as 2,000 parts per million.
Because people breathing out.
Simply by breathing. And we're not aware of it, we don't sense it. But people who've got ventilation systems do. And they're quite surprised when they go to other places, they can detect that where we can't. So as well as dealing with condensation and dampness, it makes the room much fresher. And also all the air coming in is filtered. So therefore you're getting good air coming in. And in summer, you can have a bypass system so it cools the house.
And you can inquire online about this system using ebac.com.
That's absolutely right.